Welcome back to ME 760 Engineering Analysis 1. So we will continue the same business of solving higher order differential equations. So last time we discussed the particular integral solution after we already chose the complementary function, which is the solution for the homogeneous part, and we explicitly shows that the particular integral can be determined using the method of undetermined coefficients, which is just look at the function g of x and try to seek a solution of the same form like the function g of x. So we will have an example that will strengthen this. So the example, so we have a differential equation dt y by dx square minus 3 dy by dx plus 2y equal to beta e to the power of alpha x. So if you remember, last time we stated that this is what? G of x. So in order to seek a particular solution, we will have the same form like the g of x has. So g of x is just beta e to the power of alpha x. So what will be the good choice for particular solution? Y particular equal to c e to the power of what? Alpha x. So we'll have the same form but with different what? With different coefficient. So if you substitute with this equation into equation 1, so if you differentiate this twice, this will give you what? C alpha square e to the power of alpha x minus 3c multiplied by what? By alpha e to the power of what? Alpha x plus 2e to the power of alpha x equal to beta e to the power of what? Alpha x. Then alpha x can be what? Can be phased out from the equation, and we will have c multiplied by what? Alpha square minus 3 alpha plus 2 equal to beta, and our goal is to calculate what? C. So C will be what? Beta over alpha square minus 3 alpha plus what? 2. So this is just the constant C, and the particular integral will be what? Is C e to the power of alpha x, and what's C now? Beta divided by alpha square minus 3 alpha plus 2 e to the power of alpha x. Okay, guys? And we can factor out this to be alpha minus 2 multiplied by alpha plus what? Plus 1. So again, if you have the table that I showed to you last time and we wrote it here, and in the online under the hands out section you will look for what? Alpha minus 2 and alpha minus 1. Yes, you are right.
And did your beta go somewhere?
The beta.
Yes, thank you. So if you look at the handouts for the particular solution, you will find that it is based on the form of the g of x. We will decide what will be the form of the what? Of the particular solution, and this is why we call this method the undetermined coefficient, because you have to determine the coefficient here, which is c. Okay, guys? There is a modification rule. that if you have your g of x is just some constant k multiplied by yi h of x, where yi h of x is one of your complementary function solution, the solution for the homogeneous equation. So we knew that the solution for the homogeneous equation, if we have nth order differential equation, how many solutions we will have? N. So we will have C1 y1 plus C2 y2 plus C3 y3 up to what? Up to Cn yn. So if we have your g of x equal to some constant multiplied by one of those solution, yih, where yih of x is the homogeneous solution for one of the homogeneous solution for the ODE, then you can try yp of x as just equal to c multiplied by x multiplied by yih of x, or you can try cx square yih of x if yi corresponds to a double root, so a double root of the characteristic equation. Okay guys, so this is just a modification. So now all of this, last time we discussed the homogeneous solution, homogeneous equation solution, and we stated that we have two situations for the characteristic equation. What are the two situations? You have distinct roots or repeated roots. For distinct roots you have two situations. One is all the roots are what? Are real, or you have complex conjugate pairs. And we noticed that for the case of distinct roots, we will have summation of yi multiplied by ci, yes, plus the summation of what? E to the power of gamma, e to the power of what? Gamma ix ci plus 1 e to the power of gamma ix cosine cosine x multiplied by I. This is for the complex conjugate, yes? If in the other case our solution will be non-distinct, so we'll have a repeated roots, so we need to find a set of linearly independent solution. So in order to find a set of linearly independent solutions, we found out last time that we will have what? We will have yi repeated root. Let's say the repeated root is 2 or e to the power of 2x. So then, and it is repeated 3 times. So you will have what? You will have e to the power of 2x and x multiplied by e to the power of 2x and x square multiplied by e to the power of 2x. If it is repeated 10 times, so you will have e to the power of 2x and then x e to the power of 2x up to x to the power of 9 e to the power of 2x. Okay guys, and those are linearly independent solutions. Did you figure out the play here or trick? So now we are looking for the particular solution. The first thing is to look for what? Undetermined coefficient. Look for the g of x and then try to figure out a form, similar form, substitute, get the constant c, and that's it. Very easy. Okay? Method of undetermined coefficient. The second method is called surefire method. So just, and this is for linear order differential equation with constant coefficient. So it's linear ODE with constant coefficient. So this method will be applicable to the case for linear differential equations with constant coefficient. So again, you knew that df by dx, if df by dx equal to g of x, how to solve this equation? So usually you will say f of x df equal to what? G of x dx, you will integrate plus some constant, yes? And your f of x will be just the integration of g of x dx plus this constant here. So in an operator form, d is just d by dx. So we can write the previous equation as just df equal to g of x. So I can write it as df operator d operated over the function f of x equal to g of x. So, and then you can just say that f of x is just equal to the inverse operator d operated over d of x. So if you have a differential operator, differentiation operator, what's the inverse? So d is just d by dx, and d inverse is just what? It is just the integration of d of x. This is just a review of the basics of differentiation and integration. So now let's consider first order linear ODE. And this first order ODE is just dy by dx minus alpha y equal to g of x. And we will name it 1. What's the solution for this one? Y of x equal to, you remember this is the what? This is the first order differential equation, and the form for this one was dy by dx plus p of x y of x equal to q of x. Do you remember? And we used the integrating factor. And what was the integrating factor? E to the power of integration of p of x dx. Yes, so what's p of x? Alpha, and it is constant. So integration of alpha dx is alpha x. So the integrating factor is e to the power of what? Alpha x, and then you will multiply it by here, then you will transform those two terms as what? As differential, total differential. Yes, so it will be d by dx y e to the power of minus alpha x, yes, equal to g of x e to the power of minus alpha x. Then you will get y of x, and y of x will be what? Will be c multiplied by e to the power of alpha x plus e to the power of alpha x, the integration e to the power of minus alpha x prime g of x prime dx prime. We will call this equation equation 2. Do you remember the solution? Yes? So now I can write this equation, equation number 1. So equation 1 can be written in operator form, operator D form, as D minus alpha operated over y equal to what? G of x. So what's y? D minus alpha, yes, minus 1 operated over what? Operator over g of x. Okay guys, I will call this number 3. So if we compare this equation here, y of x equal to this plus this, and y of x equal to this. By the way, this term is y what? YH, the homogeneous solution for the equation, yes? And this, what's this term? The particular solution of the equation, yes? Because this has the g of x term here. If we compare this y of x and y of x here, so you have y of x equal to c e to the power of alpha x plus e to the power of alpha x integration of e to the power of minus alpha x prime g of x prime dx prime. This is equation number 2. If I compare this with this, it will show me that this operator here, d minus alpha minus 1 operator, is nothing more than this mean that this is just an operator. Okay? What does mean operator? A mathematical operator that if you operate over a function, let's say f of x, it will give you some function g of x or something like this. Okay? So this operator here, d minus alpha, which is this one, is equal to what from here? So the first term will be the same. Yes? Yes? And the second term will be e to the power of minus alpha x prime dx. Because when you operate with this over g of x, yes? When you operate with this operator over g of x, the first one does not have any operation over g of x whatsoever. Yes? So the second one, and this is the operation here, the second one, the second term, will have e to the power of minus alpha x prime operated over what? G of x, and then you integrate over. So this is the operator that we have here. So to find the particular solution, to find the particular solution of equation 3, which is this equation, what's the particular solution from here? This is the particular solution. Yes? So we can deduce the particular solution of this equation, the operator equation, by just setting c equal to what? C equal to 0. Because if c equal to 0, I will have only the particular solution. So I can find the particular solution of 3 by just set any arbitrary constant to 0, i.e. c in equation 2 equal to 0. Okay, guys? Do you have any questions so far? Do you have any questions so far, guys? And this will give us y particular of x is just equal to d minus alpha minus 1 over gx, and this is equal to e to the power of alpha x multiplied by e to the power of minus alpha x prime g of x prime d of x prime. But this is just for the case of first order linear differential equation. Yes? What if I have a nth order linear differential equation with constant coefficients? So I can have L of y. This is nth order ODE. So I can have L of y, and this is written as operator in the operator form. So this is dn plus an minus 1, dn minus 2, plus up to a naught. This is all operated over what? All operated over y equal to g of x. So I can just, this is what type of equation? In order what? Algebraic equation. Yes, in the operator d. So I can just solve it as d minus alpha 1 multiplied by d minus alpha what? 2 multiplied by d minus alpha 3 up to d minus alpha what? Alpha n operated over y equal to g of x. Do you have any problem up to here?
So it's supposed to be n minus 1.
Which one?
The second line from the bottom. D n. You got an minus 1, d n minus 2.
D to the n plus a minus n minus 1.
Minus 1, yes. Yeah. Okay, guys. So I have it like this. Then all what we will do is just we try to get rid of the first root here. So what you will do if you want to get rid of the first root, just multiply by d alpha minus alpha 1 to the power of what? Minus 1. So you will get rid. So this operator multiplied by this operator, they are inverse. So they will give you the unity operator, which is 1. Yes, multiplied by the rest. But on the other side, you will have what? You will have d minus alpha 1 to the power of minus 1 operated over the function g of x. So when you do this, you will have, we can make it like d minus alpha 1, I can write it like this, d minus alpha 1 to the power of minus 1 it will be d minus alpha 2 multiplied by d minus alpha 3 up to d minus alpha n. I can write it as n equal to I equal to 2 up to n d minus alpha I equal to operated over y equal to d minus alpha 1 operated over g of x. Do you agree? Okay, guys. So I multiplied by this inverse operator, it will cancel this one, and I have the rest from alpha equal 2 to alpha equal n operated over y. So the multiplication is just this by multiplier from I equal to 2 up to n operated over y, and this is d minus alpha 1 to the power of minus 1 operated over g of x. So I can now say that what's the operator d minus alpha 1? Yes, this is the operator d minus alpha 1. So all what I will do is just say that my by from I equal to 2 up to n for d minus alpha I operated over y is equal to this operator, which is what? But for the particular integral c is equal to what? 0. So it will be e to the power of alpha x e to the power of alpha x prime g of x what? Prime dx prime Yes? Okay. And this will be equal to what? I will call this as h of x. Do you have a question?
Is that negative e to the integral of e to the
Yeah, yeah. So I will call this as equal to what? H of x. Now I want to get rid of the second root, which is d minus alpha 2. What should I do? So you multiply by d minus alpha 2 minus 1 here. We'll take off what? D minus alpha 2. So this will run from I equal to what? 3 to n. So this will be by from I equal to 3 to n d minus alpha I. So I will run from 3 up to n, operated over y will be equal to what? D minus alpha 2 minus 1 operated over h of x. And what's h of x? So we will make it as, what's the operator d? E to the power of alpha x, e to the power of minus alpha x prime operated over h. But what's h of x? E to the power of what? Alpha x, e to the power of minus alpha x, g of x prime dx prime. Yes? Okay, guys? So we will keep doing this until we will take off all the roots, so that we will end up with y only. We'll end up with what? With y only. So we got y in a left-hand side alone, and the rest of everything in the right-hand side. So we isolated our solution, which is y particular, in one side, and then we put everything on the other side. Did you understand what we're trying to do now, right now? Try to isolate our solution on one side and make the rest of the solution on the other side. It's a brutal force way. This is why we call it surefire. So after you do this for n times, and you will get rid of this, you continue this fashion. So yp continue same process until you get y alone. So y of p will be just equal to e to the power of alpha n x integrated, multiplied by the integration of e to the power of minus alpha n minus alpha n minus 1. Okay, guys? Because when you see here, this is alpha. This will be the very early beginning. This was alpha what? Alpha 1. Yes. Then you have alpha what? Alpha 2, but this is alpha what? Alpha 1. Yes. So you will have what? E to the power of alpha 2 minus alpha 1, yes? Outside, e to the power of alpha 2 minus alpha 1, all multiplied by what? By x. So this is why you have e to the power of alpha n minus alpha n minus 1. And this will be multiplied by e to the power of minus alpha n minus 1 minus alpha n minus 2 x n minus 1. Blah blah blah, e to the power of up to e to the power of alpha 2 minus 1 minus x e to the power of minus alpha 1x g of x dx 1 dx2 up to dxn. I know that it's very huge here. So let's solve the same example that we solved at the early beginning of the lecture. d2y by dx square minus 3dy by dx plus 2 what? 2y equal to beta e to the power of alpha x. For this solution, for this equation, what we did, direct substitute with c e to the power of alpha x, and we got the constant c, and the constant c was beta over alpha square minus 2 alpha plus 1. Yes? Minus 3 alpha plus 2. Yes? So now let's try this method. So all what we will do, we will transform this equation to operator equation. So this will be d2 minus 3d plus what? Plus 2 operated over y equal to beta e to the power of alpha x. Then you will decompose this to what? d minus 2 and d minus 1. So what's alpha 1? This is alpha 1. And what's alpha 2? 2. Those are the alphas. You can pick whatever you want. Beta e to the power of alpha x. If you tell me where is your ear, I will tell you here it is. Instead of this. But anyway. Okay, guys. So you have alpha 1 and alpha 2. Now go and substitute in your formula for yp. So yp will be e to the power of alpha what? The maximum here is what? 2. And alpha 2 is what? Alpha 2 is 2. So this would be e to the power of what? 2x multiplied by e to the power of minus 2 minus 1 x multiplied by integration of e to the power of minus x. G is beta e to the power of alpha x dx. So you will integrate this one first. So what's e to the power of minus x, e to the power of alpha x? Beta is constant, it will be out here. And this will give you alpha minus 1 multiplied by what? By x. So when you integrate, this will give you what? Beta divided by what? Yes? Okay, when you have this and you multiply by e to the power of minus x, e to the power of minus x, and here you have e to the power of minus x, so it will be e to the power of minus 2, yes, alpha minus 2x. So this yp will be just e to the power of 2x multiplied by the integration of what? E to the power of alpha minus 2x dx multiplied by what? Beta over alpha minus 1. What's this integration? So this will give you e to the power of 2x multiplied by 1 over what? Alpha minus 2. And this is alpha minus 1. And here is beta. And what's the integration for this? E to the power of alpha minus 2. And this is x. So alpha x minus 2x plus 2x. So this will give you what? Beta alpha minus 2 alpha minus 1, which is same solution like the undetermined coefficient.
Do you need integration coefficients as you go through that?
I need what?
Coefficients of integration on each one you do.
What's the coefficient of integration?
Well, normally if you don't have limits on an integral.
But we said that with all the c's we will be taking as 0 for particular. If you remember, I said that you will take all the coefficient c's equal to 0. Okay, guys? Does it make sense for you now, the process? Somebody will ask, okay, when you will use it, of course, if you have exponential function, cosine function, blah, 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 it's very easy to use in the integration method here, in this integration here. Yes? But what if you have sec of x squared e to the power of x, something like a very complicated function? Don't try this method. It would be very, very difficult. Okay, guys? Then we will come to how many methods now for the particular integral? Undetermined, coefficient, and the surefire. And then we will come to the method of variation of parameter. And this method was invented by Lagrange, and it is for linear differential equation with variable coefficient. Instead of constant coefficient, it is with variable coefficient. So method of variation of parameters. Lagrange. And this is for linear ODE with variable coefficient. So let's assume we have a variable, a second order differential equation in the form y double prime b of x y prime plus g of x y equal to r of x, and this is equation number 1. The solution for this equation usually will be y homogeneous of x will be c1 y1 of x plus c2 y2 of x, and those are the two independent solutions. This is the homogeneous equation solution. Okay? So we will seek, once we solve the equation, find out what's y1 of x and what's y2 of x, we will seek a particular solution. This is the method for variation of parameter. We will seek a solution yp of x as just a combination of some function u of x y1 of x plus v of x y2 of x. So we'll try to find the function u of x and the function v of x that we can multiply those two functions. Here we can multiply it by the linearly independent solution that we already calculated from the homogeneous solution. So what you will do is you have the differential equation, take off r of x equal to 0, solve for what? For the homogeneous equation. You will get the complementary function solution, which will be in the form of c1 y1 and c2 y2, because this is a second order differential equation. Then we will assume or we will seek a solution for the particular integral to be u of x, y of x plus v of x, y of x2. Then we'll call this equation number 2. So this equation number 1, will give us a condition for what u of x and v of x should be, and we have to impose another condition. So equation 1 impose a condition on u and v. Why? Because if you substitute with up here in this equation, it should satisfy out of what? Out of x, and you will get what? You will get some condition for u and v. So we need another condition because we have two unknown function u and x. So let's assume that this condition will be u1 y1 plus v1 y2 equal to 0. Put this like 3. So if you differentiate y particular once, this will give you u multiplied by y1 1 plus u prime y1 plus v y2 prime plus v prime y2. Yes, guys? But from the condition that we impose here, y prime u prime y1 u prime y1 and plus v prime y2 should be equal to what? 0. So this will give us uy1 prime plus v y2 prime. So differentiate this again. So y double prime p is equal to what? Is equal to u prime multiplied by y prime plus uy 1 double prime plus v prime y2 prime plus vy2 double prime. We will call those two equation number 4. Okay, guys? Do you have any question? Just the first multiplied by the differentiation of the second plus the second multiplied by the differentiation of the first, and again here. Okay, so you will take equation number 4 and equation number 2. So you will take yp, okay, and you will take yp prime and yp double prime, and you will substitute here. So 2 and 4 in 1. So you need y double prime, here is y double prime, and you need p of x, y prime, here is y prime, and then you need g of x multiplied by y, p, here is yp equal to r of x. Just substitute. Then when you substitute, you will end up with the following formula. It will be U Y1 double prime plus P Y1 prime plus Q Y1. This is, we call it Q instead of G. Okay, guys. Plus V multiplied by same Y2 double prime plus P Y2 prime plus Q Y1 plus U prime Y1 prime plus V prime Y2 prime equal to R of X. Or you will reduce it to U1 U prime Y1 prime plus V prime U2 prime equal to R. Of course, this equation is equal to what? R here and R here. When you simplify this equation, you will reach to this U1 prime Y1 prime plus V1 V prime U2 prime equal to R. And what's the condition that we impose here? U prime Y1 plus V prime Y2 equal to what? 0. So those are two equations in two unknown. To solve it, we can write Y1 there's no primes in those. So Y1 and Y1 prime and Y2 and Y2 what? Prime operated over U prime and V prime equal to 0 and R. In order to have a meaningful solution for U and V, you have the determinant should be equal to what? So that you will have a non-trivial solution for U and V. So your determinant should be equal to 0. If it is not 0, this means that V and U are zeros. So your determinant should not be equal to 0. So this is the Wronskian, which is the determinant of Y1, Y2, Y1 prime, Y2 prime should be equal to 0. And you knew that Y1 and Y2 are linearly what? Independent. So from Kramer's rule that we just discussed in the previous matrices, so this would be U prime will be just equal to Y1 0 R Y1 prime. If you return back to your matrices divided by this is V prime, and U prime is just equal to 0 Y2 R Y2 prime divided by omega. So this one I can call it also equal to y1 r divided by omega, y2, sorry. And this is equal to y1 multiplied by this is 0, and this is y2 r divided by omega, and this is y1 r divided by omega. So u and v will be calculated. How you calculate u and v from those? Those are the u prime and v prime. How you will calculate u and v? Integrate. So u will be just the integration of what? Negative. U prime has a negative sign here. So it will be negative y2 r over omega multiplied by dx, and v will be y1 r over omega dx, and then you will have your y of particular is just equal to y1 multiplied by u, and u is just y1 r over omega dx. There is a negative sign, plus y2 multiplied by y1 r over omega d of x. Let's again apply this to the same example. Y double prime minus 3y prime plus 2y pe alpha x. Again, d minus 2, d minus 1, y beta alpha x. What's y1? E to the power of x. And what's e2, y2? E to the power of what? So solve this equation when this is equal to 0. When this is equal to 0, you have how many solutions? 1 and 2. So one will be e to the power of x, the other one e to the power of what? 2x. So what's y1? y1 prime e to the power of what? X. And what's y2 prime? 2 e to the power of what? 2x. Then what's the Wronskian? It's equal to what? y1 is what? E to the power of x. y1 prime e to the power of x. y2 prime. So what's this? If you do this, this will give you e to the power of 3x. So let's look for y2r over omega dx. What's y2r? This is what? U. Yes? And this will give you e to the power of 2x multiplied by beta e to the power of alpha x, which is r function r divided by e to the power of 3x dx, and this will give you beta e to the power of alpha minus 1 x dx, and this will give you beta over alpha minus 1 e to the power of alpha minus 1 x. What's y1 r over omega? If you do this, this will give you beta over alpha minus 2 e to the power of alpha minus 2 x. So y particular integral, if you substitute this in this equation for the particular integral, you will get beta e to the power of alpha x divided by alpha minus 2 multiplied by alpha minus 1, which is what? Same solution. Yes? So how many methods now we discuss? 3. Which one? Undetermined coefficient. Look for the form of the g of x or r of x, choose the same form with a different coefficient, substitute it in the equation, seek the value of those undetermined coefficient, return it back and substitute it in the form that you pick up. Then the surefire, if you have a simplified function g of x that you can integrate easily, then the last method is what? The variation of parameter, and we can extend this variation of parameter. We just showed for what order, second order differential equation. So we can extend it to nth order differential equation, and then your Wronxian will be just what? y1 prime, y2 prime, y3 prime up to yn prime, and y2 up to yn2 prime. So it will be something like this. y1 prime, y1n, y2 prime, y2n, and yn1, yn2, ynn. So this will be the Wronxian. Or up to n minus 1, sorry. Okay, guys? Okay? So that's it for today's lecture. Do you have any questions? Nothing? We'll continue next time.
How long do you think you'll be in your office today?
I have a class from 1:30 to 2:30. Then I have a meeting, and I will be back at